So in the previous lesson, we learned about what is a mole. Okay, we take a look at mole as a unit. So in chemistry, mole is a unit to represent the numbers of particles. Okay, so we saw that mole is actually 6 times 10 to the power of 23 particles. Then we also take a look at the next one, which is molar mass. So this molar mass is the mass of 1 mole of substance. Okay, this molar mass can be used for all substances in all states. So it can be used for solid state, liquid state, and gaseous state.
Then we take a look at molar volume. So molar volume is the volume of 1 mole of any gas.
Which means it's only used for gaseous state substances. Okay, it's only used for gaseous state substances. And then the last one, referring to the amount of substance dissolved. Okay, it's amount of substance dissolved, so it can be amount of mole per unit volume, which means that this is only applicable for solution in aqueous state. Okay, so we take a look at how to calculate the number of moles when they are in solid, liquid, gas, and aqueous state. But we have not really understand. So what if we calculate already? So what if we calculate the mass? So what if we calculate the concentration? So what if we calculate the volume? How do we use that? Okay, so in this part, we're going to use moles to calculate reactions. Okay, so in all reactions, there will be A and B mixed together, or A decomposes to produce B and C. So we are trying to find out if, for example, A plus B to form C, we are trying to find out how much of A, how much of B, okay, will form C. So we are trying to find out the amount. Okay, so this part here is on chemical calculation. So that is why Mr. Avogadro say, do it with the moles. So this is a chapter overview. Okay, we'll take a look at calculations from chemical reactions. And then we'll look at specifically gases. Okay, so this is about mole and molar mass. And then this is mole and molar volume for gases only. And then for volumetric analysis, when you see volume, it is referring to aqueous solution. Then we'll take a look at limiting reactants. Okay, sometimes one reagent is in excess, then the other one is limiting. Then of course, the last part is we'll take a look at percentage yield and purity. Okay, we aim to reach 100% yield, but sometimes we can't have 100% because of accidents or because the substance is impure or reaction is not completed. Okay, then of course, percentage purity. Okay, so for the first part, we'll take a look at calculations. Okay, so we're going to take a look at how to connect molar mass and volume together. So first of all, I'm going to introduce to you this new term called stoichiometry. Now you don't need to memorize. Okay, but this whole topic is on stoichiometry. Okay, so what is exactly stoichiometry? Okay, so stoichiometry requires you to first form the equation. Okay, you will need to form the equation first. Okay, because it tells you the reactants that you're going to use, and of course the products that are formed. Okay, so the balance equation tells you need A and B to form C. Okay, it tells you the reactants and the final products. Okay, and then it gives you information such as the state of the reactants and products. So when you look at the equation with state symbols, straight away you know that this substance is in what state? Solid state, gaseous state, liquid state, etc. Okay, and then the last one is of course this term called mole ratio. So what is mole ratio? So ratio means relatively, something to something. So what is actually mole ratio? We are looking at the amount of unit for each reactant to form the product. Okay, so we'll show you some examples. Okay, so in essence, stoichiometry is to measure the quantitative relationships of reactants. Okay, it also tells us the amount of product formed. Okay, so we'll take a look at it. So basically, it just tells you the relationship between the reactants and between reactants and products. So let's take a look. So this equation tells me that to make 1 mole, okay, if I want to make 1 mole, I will need 2 cracker squares. Okay, one top and bottom. And then I will need 1 marshmallow as the filling. And I need 3 chocolate squares. Okay, so to make this more, I need these substances. So the ratio here is 2 is to 1 is to 3 is to 1. So mole ratio means I need 2 units. Okay, I need 2 units of this cracker squares, 1 unit of marshmallow, and 3 units of chocolates to make just 1 unit of small. Okay, so this is what we call mole ratio. Remember, mole is a unit. Okay, it is a unit. Alright, so if I ask you, now I have 4 units of cracker squares, 2 units of marshmallows, 6 units of chocolate squares. How many smalls can I make? Is your answer 2? Okay, if your answer is 2, which means you know how to use mole ratio. Okay, so basically, it is how much reactants used determine how much product form. Okay, so I repeat, stoichiometry means how much reactants used will determine how much product form. And of course, among these reactants, okay, we also can see the relationship, which means I always need twice the number of cracker squares versus marshmallow. Okay, now my favorite, which is double McSpicy. Okay, not just McSpicy, but double McSpicy. So how many pieces of bread do I need? I need 2. Okay, I need to balance this equation first. So to make one double McSpicy, I need 2 pieces of bread, 2 McSpicy patty, 1 piece of lettuce. And then I form 1 double McSpicy. Okay, so this is my balance equation. It tells me the relationship of the reactants, how many units to make 1 unit of product. So the mole ratio for this is 2, 2, 1, 1. 2 is to 2 is to 1 is to 1. Okay, so now I have 6 pieces of bread, 6 pieces of chicken patty, 3 pieces of lettuce. How many sets of double McSpicy can I make? Is your answer 3? Okay, so McDonald's is open now. You can go and get this double McSpicy. Okay, so stoichiometry is to look at the relationship between the reactants and the products. So in this case, okay, we go back to chemical reaction. To make water, I will need to react hydrogen and oxygen together. So it's a combustion reaction between hydrogen and oxygen. So I need to balance the equation. And in this equation, there is also a state symbol. Okay, so 2 units of hydrogen will require 1 unit of oxygen, and then they'll produce 2 units of water molecule. So instead of using the term units, okay, we use a chemical term called moles. Okay, so 2 moles of hydrogen reacts with 1 mole of oxygen to form 2 moles of water molecules. Okay, if I want to look at it in terms of mass, okay, so how should I do it? Okay, ask yourself this, what is the mass of 2 moles of hydrogen? Because in reality, we don't say 2 moles of hydrogen, 1 mole of oxygen. Okay, we can calculate mass. So when we want to react this reaction, I will need to weigh hydrogen and I need to weigh oxygen. So if I want to convert to mass, how will it be? So we need to take a look at molar mass, okay, with your MR. Okay, 1 mole of oxygen, okay, the molar mass is 32 gram per mole. Okay, and then for hydrogen, molar mass of hydrogen is 2 gram per mole, because 2 times 1, correct? 2 times 1, which is 2. Okay, then same thing, this is 2 times 16 gram. So if I want to convert it to mass, okay, 1 mole is 2 gram, so now I have 2 moles. So I have 4 grams of hydrogen reacting with 32 gram of oxygen. And then what is the mass of water? Take some time to calculate. Ask yourself what is the MR of water first. Okay, 2 times 1 plus 16 equals to 18 gram per mole. Per mole. So now I have 2 moles, I multiply by 2, it will be 36 grams. Okay, so if I want to form 36 grams of water, I will need to weigh 4 grams of hydrogen and 32 grams of oxygen, and then I combust them together. Okay, let's take a look at another example. So in this case, we have magnesium in a solid state reacting with copper 2 oxide in a solid state. And in this reaction, it formed 1 unit of magnesium oxide and 1 unit of copper solid. So what is the mole ratio of this equation? So if you take a look at this equation, it's 1 unit of magnesium, 1 unit of copper 2 oxide. Okay, so we can see as 1 mole of magnesium reacting with 1 mole of copper 2 oxide. And in this reaction, 1 mole of magnesium oxide, 1 mole of copper is formed. So if I want to convert this into mass, okay, so if I want to find out, okay, how much mass of magnesium do I need to weigh? Okay, what is the mass of copper 2 oxide do I need to weigh? Okay, and what is the mass of these two products formed? Okay, so I need to calculate. So since they are all 1 mole, we'll look at molar mass. Okay, so 1 mole of magnesium is 24 gram. 1 mole of copper 2 oxide is 80 gram. Okay, and 1 mole of magnesium oxide is 40 gram, and 1 mole of copper is 64. So how do I get all these numbers? They are from your periodic table. Okay, you look at their AR. Okay, so for example, for this copper is actually 64 gram per mole.
And this oxygen is 16 gram per mole.
So you look at their periodic table, their individual AR, and then you add them together. Okay, so what conclusion can you get from this example? Okay, I started off, okay, my reactants are total is 104 gram. Then if you take a look at the product, this is 40, this is 64. If I add these two together, total is also 104 gram. So what do you notice about this? Do you realize that the reactants, the mass of the reactants and the mass of the products, they are the same? Okay, so they are all equal. Whatever I add in, okay, the amount is produced, the total amount is the same. Okay, the total mass of the product will be the same as the mass of the reactants. So, stoichiometry allows us to calculate masses and volume. We'll do some examples first. Okay, so the idea of stoichiometry is really to allow us to calculate the mass of a substance. Okay, so for example, I give you the mass of one substance. You're able to use stoichiometry to predict, to calculate the amount produced, vice versa. So, for example, in this case, if I use 1 unit of this, if I use 1 unit of magnesium, I know that I will also need 1 unit of copper 2 oxide. Okay? And if I use 1 unit of magnesium, 1 unit of copper 2 oxide, I know that I'll produce 1 unit of magnesium oxide. And of course, 1 unit of copper. So they are vice versa. Same thing, likewise, if I say I want to produce 1 unit of this and 1 unit of this. So I ask you to work backwards. How much of this? What is the number of moles do I need? And I know that from this balance equation, to produce 1 mole of this, I will need 1 mole, Okay? So if I use mass, 40 gram of magnesium oxide, 64 gram of copper, okay, will be formed if I use this amount. So I can go forward, I can calculate from reactants to products. I can also use the products to predict how much reactants I need. Okay, so this is the idea of stoichiometry. So it's just comparing ratio between reactants and products. Okay, so let's try a question. Okay, page 4 of your notes. Alright, so in this case, they say magnesium reacts with dilute hydrochloric acid to produce these two. Now in chemistry, okay, some of the questions, they don't tell you the products. If this is a reaction that you have learned, acid plus metal, they will not tell you the products. So you will need to know the reactions. Okay? So first step you need to do is always write the balance equation. Okay, so you always need to write the balance equation first so that you can get the number of moles. You can get the mole ratio. So in this case, acid plus metal, you will form salt and gas, which is your hydrogen. You will form salt and hydrogen gas. Then of course, I will need to balance my equation. Magnesium chloride Mg2 plus Cl minus. So my formula is MgCl2. I have 2 Cl here. I will need to balance. So I multiply by 2. Okay, so in this case, the mole ratio is 1 is to 2 is to 1 is to 1. Okay, 1 unit of magnesium will react with 2 units of acid to produce 1 unit of this and 1 unit of hydrogen gas. Okay, so now in the question, they tell you 2 gram of magnesium ribbon is formed. So you are given 2 gram of this. You're given 2 gram of this. Okay, and the question asks, what is the mass of magnesium chloride? Mass, okay, so you need to find out. This is mole ratio. Okay, this is not mass ratio. This is not mass ratio. What do I mean by this? It means you cannot be 2 gram, 4 gram, 2 gram, 2 gram. This is not how it works. Balance equation tells you the mole, okay? Tells you the unit. So 1 unit will react with 2 units to form 1 unit of this and 1 unit of this. And it is not the same as mass. It is not the same as mass. Okay? So since we are comparing mole ratio, we always need to calculate moles. Okay? We must calculate number of moles. Okay? Because number of moles is the same as number of units. Okay? So what is the next step? Okay? So the next step will be determine the number of moles of magnesium. Because I have 2 grams here. Okay? 2 grams. So recall, molar mass, okay, molar mass is mass of 1 mole of substance. Okay, magnesium in your periodic table, magnesium is 24 gram per mole. 24 gram per mole. So 1 mole of magnesium is 24 gram. So now you are given 2 gram. You need to find the number of moles of magnesium. You need to find this. So how to find? Mass given, which is 2 gram here, divide by 24 gram per mole. Okay, and you will get 0.0833333 mole. Okay, intermediate step, give to 5SF. Okay, intermediate step, give to 5SF. Otherwise, it will affect the accuracy of your answers. Okay, so I've done this. I calculate the number of moles of magnesium. Okay, so now I want to calculate this. Okay, I know that this is 1 unit, this is 2 unit, this is 1 unit, and 1 unit. So since I'm interested in magnesium chloride, I'm just going to compare these two, magnesium and magnesium chloride. Okay, so in this case, the mole ratio is 1 is to 1. Agree? 1 is to 1. So what does this mean? Okay, it means that they are the same. If this is 1 mole is to 1 mole, and now you are given this amount, 0.083333 mole, then this will be 0.083333 mole at this point. Okay, all right, so 1 mole of magnesium produces 1 mole of magnesium chloride. Likewise, 0.083333 mole of magnesium chloride will be produced. Okay, so 1 mole of magnesium produces 1 mole of magnesium chloride. 0.083333 mole of magnesium will produce 0.083333 moles of
Magnesium chloride.
at this point. Okay, now the question asks for mass, so we don't stop here. Okay, 1 mole of magnesium chloride, okay, we need to find the molar mass. Okay, mass of 1 mole. So molar mass of magnesium chloride is 24 plus 2 times 35.5. Okay, so this is the molar mass is 95 gram per mole. Okay, 1 mole is 95 gram. So now you are given 0.083333 mole. Okay, what is the gram here? So how do you do it? You use the equation. Okay, so this is the equation. Okay, your formula, mass over molar mass gives you the number of moles. Okay, so now I want to find the mass. I will multiply these two together. So 0.083333 mole multiplied by the molar mass, which is 95, I'll get this. And I leave my answer in 3SF. My final answer is in 3SF. Okay, so with this, you try the next question on page 4. Give yourself about 4 to 5 minutes to complete. Okay, so let's take a look at this example here. Right, so you are given aluminium and it reacts with oxygen to produce aluminium oxide. So first of all, you need to write the balance equation. Aluminium metal is just aluminium. Oxygen, recall what is the formula of oxygen gas. Okay, it is O2. And then what is aluminium oxide? Is Al2O3. Okay, if you cannot remember, it's Al3 plus O2 minus. Okay, so together is Al2O3. Okay, so the question is saying that how much of magnesium is needed to produce 3.4 gram of this. Okay, so now you need to write the balance equation. Okay, so the first step is, okay, aluminium plus oxygen. And they tell you that it forms aluminium oxide only. So only one product. So what you need to do is you need to balance. Okay, so take some time to balance. So that is what I meant by you need to know the formula well. Okay, if you don't know this formula or you cannot come up with this formula, then you will not be able to do the whole chemical calculation. So your basic for formula writing is important. Then the second one is, of course, you need to know how to balance the equation. Okay, so recall whatever that we learned in semester 1. Now we are all using them together. Okay, so in this case, I know that 4 units of this requires 3 units of this. 2 units of this will be produced. So this is what we call the mole ratio. So always need to calculate the moles. Okay, so now you are given 3.4 gram. So I want to produce 3.4 gram of this. Okay, I need to calculate the number of moles. So how many moles are there in this 3.4 gram? Okay, so what I understand here is that I need to form 3.4 gram. First of all, I know that my molar mass is 2 times 27 plus 3 times 16. Okay, so my molar mass is 102. Now this molar mass of aluminium oxide refers to 1 mole. Refers to 1 mole, only 1 mole. Okay, so I need to calculate the number of moles in 3.4 gram. Okay, so I use the formula, step 2. Okay, number of moles of aluminium oxide will be mass over molar mass. So mass is 3.4 gram divided by 102 gram per mole. And from here, I get 0.033333 mole. Okay, so this is step 3. I calculated this. Okay, so from my equation, I'm interested in the amount of aluminium. So aluminium is to aluminium oxide. The mole ratio is 2 is to 4. Okay, take note, molar mass is always referring to 1 mole. So we don't care about this 2. We don't care. Okay, so molar mass is always referring to 1 mole. Then when we compare the equation, we take into account of this number. Okay, so aluminium is to aluminium oxide is 4 is to 2. Okay, then I simplify, become 2 is to 1. So if my aluminium oxide is 0.033333 mole, this one will be 0.066666 mole. Okay, so number of moles of aluminium is this. Okay, to form 3.4 gram of aluminium oxide, I will need this. So the question asks, what is the mass of aluminium required? So AR of aluminium, 1 mole of aluminium is 27 gram. 1 mole of aluminium is 27 gram. So now I'm interested in the mass for 0.066666 mole. So mass of aluminium will be 0.06666 mole times 27 gram. And then I will get 1.79982 gram. I round it up to 3SF. Okay, I round it up to 3SF, I'll get 1.80 gram. So this is my final answer with the unit. Okay, so this is how we do it. Okay, so take a look at this again. I repeat, aluminium reacts with oxygen to form aluminium oxide. Okay, so we form a balance equation first, balance them so that you can see the mole ratio. So this is 4 is to 3 is to 2. So the question says, I need to produce this amount. I want to produce 3.4 gram of the oxide. Okay, so how much of aluminium do I need? So I have 3.4 gram of this. How much of aluminium do I need? So I always calculate to the number of moles because we are always comparing in terms of mole ratio. So I calculate mass over molar mass. Molar mass of aluminium is 102. Okay, 3.4 divided by this, I'll get this number. Okay, leave it to 5SF first. Then I compare mole ratio. Since I'm only interested in aluminium, I just compare these two. Mole ratio is 4 of aluminium, 4 units of aluminium will produce 2 units of aluminium oxide. Okay, so ratio is 4 is to 2. I simplify, 2 is to 1. So for every mole of aluminium oxide produced, I will need 2 moles of aluminium. Since I have produced 0.033333 moles of aluminium oxide, I multiply by 2, I get this. So the question asks for mass. What is the mass of aluminium in this number of moles? So I use the formula. Molar mass, okay, 24 gram per mole. I have 0.066667 mole. I multiply these two, I will get 1.79982 gram. I round it up to 3SF. That's my final answer. And don't forget the unit because your statement here is mass of aluminium. Okay, so this is how we do stoichiometry. Okay, so in the previous example, you are told to find out the mass of substance produced if you are given the mass of one substance. So you are given the mass and then you are told to find unknown mass. Okay, likewise, page 5, okay, you are told to find unknown mass, but now you are given a volume. So now you are given a volume. So what do I mean by this? Okay, so take a look at this example. Lead 2 nitrate decomposes when they are heated, and this is the reaction. Okay, you are given this balanced chemical equation. Do you have to memorize? No need. If the reaction is unfamiliar to you, don't worry, they will give you the balanced chemical equation. Okay, so here they ask you, calculate the mass of lead 2 oxide. So you are told to calculate the mass of this. Okay, and then they tell you, calculate the mass of this when 6 dm cube of NO2 is produced. So they only give you the volume. Okay, so instead of mass, they give you the volume. So how do you do it? Likewise, the method is the same. Always have the balance equation, always have the mole ratio. Okay, so the common thing is the mole ratio. So in this case, you have 2 moles of this, produce 2 moles of lead 2 oxide, and you produce 4 moles of nitrogen dioxide and 1 mole of oxygen. Okay, so this is the mole ratio. So you need to calculate mole. So first of all, you're only given this value. So you work from this value. So what is the number of moles of NO2? Okay, recall. Since you see volume and this is a gas, straight away think of it of molar volume. So molar volume, recall, is volume of 1 mole of any gas. And it is 24 dm cube per mole. 24 dm cube per mole. So now, you are given 6 dm cube. How many moles are there in 6 dm cube? So you need to use the formula. Okay, we call the formula. Number of moles equals to volume of gas divided by 24 dm cube per mole. Okay, 1 mole is 24 dm cube. So how many moles is 6 dm cube? Alright, so I give us 6 dm cube. So 6 dm cube divided by 24 dm cube per mole. Okay, if you look at the equation, actually I cancel out the unit. I'm only left with mole. So 6 dm cube is 0.250 mole. Okay, so now I need to compare the mole ratio, which is PbO to NO2. Okay, so PbO to NO2, I compare these two only. Okay, the mole ratio is 2:4. So I always compare the numbers. So 2 units is to 4 units. If I simplify them, it will be 1:2. Okay, since I have 0.250 mole here, what will be the number of moles for lead-2 oxide? I will divide by 2, and this is the number of moles of lead-2 oxide. Okay, so continue. So 0.25 moles of NO2 will produce 0.125 of lead-2 oxide. Okay, so do I stop here? No, because question asks for mass. I only have the number of moles now. So I will need to continue to find the mass. Okay, so number of moles of lead-2 oxide. Okay, so continue. So I cannot stop here because question asks for mass. Alright, so I will need to continue. So using the formula, this is lead-2 oxide, molar mass. Okay, molar mass of lead-2 oxide, I need to find the MR. Okay, so for lead-2 oxide, the MR is 207 gram per mole plus 16 gram per mole is equivalent to 223 gram per mole. Okay, so this is per mole. Per mole is 223 gram. Okay, so I only have 0.125 mole. So I use this formula. Mass of lead-2 oxide will be number of moles multiplied by molar mass. This is my answer. Round up to 3SF, 27.9. Okay, so the method is the same. Just that now instead of mass, you are given a volume. So you always convert it to mole ratio. So you always convert it to number of moles because you are always using this as mole ratio. We don't say mass ratio, we don't say volume ratio, we are using mole ratio. So always convert to moles. Okay, so try this example here on page 5. Give yourself 4 to 5 minutes. Okay, likewise, this equation is given to you. Okay, zinc sulfide, zinc is Zn2 plus, sulfide is group 6, so 2 minus, so zinc sulfide reacts with oxygen gas, and this is the balance equation. So the question asks, what is the mass of zinc sulfide needed to produce 12 dm cube of this? Okay, so you're given this volume. Alright, so you need to do the mole ratio. So if you take a look at this equation, it is 2 moles react with 3 moles of oxygen to produce 2 moles of zinc oxide and 2 moles of sulfur dioxide. So this is your mole ratio. Okay, so first of all, you are given this. Calculate from here. Calculate what is the number of moles of SO2. So number of moles of SO2 will be volume divided by molar volume. Okay, so 1 mole of gas is 24 dm cube. So 12 dm cube will be 12 divided by 24 dm cube per mole. Okay, is 0.5 moles. Exact value. Okay, so now I have 0.5 mole of SO2. So I'm interested in zinc sulfide. So I compare these two will do. So from this equation, 2 moles of zinc sulfide will produce 2 moles of SO2. So you are to produce this number of moles. Question asks you to produce this number of moles. So to produce this number of moles, I will need 0.5 moles of zinc sulfide. So I don't stop here because I'm interested in the mass of zinc sulfide. Okay, so I will look at the MR. So the molar mass of zinc sulfide will be 65 plus 32. Okay, so the molar mass is 97 gram per mole. So per mole is 97 gram. So you are given only 0.5 moles. So mass of zinc sulfide, okay, the units is in gram, will be number of moles multiplied by molar mass. So, number of moles is 0.5 mole multiplied by 97 gram per mole. So, per mole is 97 gram. Half a mole will be 48.5 gram. And leave my answer always to 3SF. Always. Okay, so my final answer, mass of zinc sulfide is 48 gram. Okay, so, okay, to recap, zinc sulfide react with oxygen to form this. Okay, you are given 12 dm³ of sulfur dioxide. Okay, so find the number of moles first. Always find the number of moles. 12 divided by 24. Okay, this is the number of moles. So I compare zinc sulfide with sulfur dioxide. Mole ratio 2:2. Simplify 1:1. 1 mole of zinc sulfide will produce 1 mole of sulfur dioxide. Okay, so using the mole ratio, 0.5 moles of sulfur dioxide produced will mean that I use 0.5 moles of zinc sulfide. Then I need to find the mass. So what is the mass? So mass is number of moles multiplied by molar mass. Okay, is 48.5. Leave it to 3SF. Okay. Okay, so here we are given the volume and we are told to find the unknown mass. Alright, so now moving on. I can also find the unknown mass using a given concentration. Okay, so let's take a look at your notes, page 6. Okay, so you are going to tell me what is the unknown mass using a given concentration. So just to recap, concentration, we are always referring to solution. Solution is in aqueous state. Aqueous means dissolve in water. Liquid state is not equivalent to aqueous state. Okay, this is dissolve in water for aqueous state. Liquid state means melt the solid. You melt the solid, become liquid state. There is no water. So there are two different things. Alright, so now you're given this reaction. Iron 3 chloride, sodium hydroxide, and you form this. Okay, in fact, this is your QA, qualitative analysis, precipitation. Okay, this is your insoluble solid. So once you see aqueous, and solid, right, straight away this is precipitation, formation of insoluble solid. Okay, so focus on this calculation first. This is a balance equation. So they tell you, okay, to find the iron 3 hydroxide produced. Okay, so I want you to find the mass of this when you are given this volume and this concentration of NaOH. Same thing. Always find the number of moles. Okay, so if you take a look at this equation here, recall mole per dm³, the unit for concentration, is equivalent to number of moles divided by volume of solution. Okay, now take note, this volume of solution, very important, please write it down. This volume of solution is not molar volume. This volume of solution is not molar volume. This molar volume is 24 dm³ per mole for gases only. For gases only. In this case, we are talking about solution, aqueous state. They are not the same. They are not the same. So this is the part where students are always confused. Okay? So determine the number of moles of sodium hydroxide. So you are given this concentration, you are given this volume. Okay, so you use this equation. Concentration is 2.00 mole per dm³. So number of moles of NaOH equals to 2.00 mole per dm³. This is the concentration. This is this, yeah, put tick. And then they tell you, you are given 30 cm³. 30 cm³. And this unit is in dm³. So I need to convert. I must convert it into dm³. So multiply 30.0 divided by 1000. This is my dm³. So these two together will form 0.06 mole. So the number of moles of sodium hydroxide is 0.06. Okay, so the question is only interested in iron 3 hydroxide and sodium hydroxide. Okay, so I erase this part here. Okay, we are only interested in this and this. Okay, so if I just compare these two, the mole ratio is 3:1. Okay, so if I do the mole ratio, NaOH is to iron 3 hydroxide. This is 3 units, this is 1 unit. So 3:1. Okay, so what is the number of moles of iron 3 hydroxide? So since this is 3:1, number of moles of iron 3 hydroxide will be 0.06 mole divided by 3 will be 0.02 mole. Okay, so 0.02 moles of iron 3 hydroxide is produced. What is the mass? Okay, so likewise, I will need to calculate the molar mass of iron 3 hydroxide. And molar mass of iron 3 hydroxide will be 56 plus 3 times 17 equals to 107 gram per mole. Okay, so per mole is 107 gram. You are only given 0.02 moles. Okay, so mass of iron 3 hydroxide will be molar mass multiplied by 0.02 moles, cancel, equals to 2.14 gram to 3 SF. Okay, so this is how you calculate. So likewise, we are always using the number of moles to compare the ratio. Okay, and then we calculate depending on the formula. Okay, so if we are using concentration, we use the concentration formula. If we are using volume of gas, we use molar volume. Moving on, instead of finding unknown mass, I can also find out the unknown volume using a given mass. So previously, I gave you the volume and then I asked you to find what the unknown mass. Okay, now I can also give you the mass to find out what is the unknown volume. So these two I can change. Okay, I can change to unknown volume. I can also change to unknown mass, but actually they are all talking about the same thing. Okay, at the end of the day, they are just mole ratio. Okay, so for this part here, okay, maybe you can pause the video to try writing the balance equation before you see my answer. Okay, actually it's the same question. Magnesium plus hydrochloric acid. So magnesium plus hydrochloric acid. Okay, I know that they form salt and hydrogen. So my salt here is magnesium chloride and hydrogen gas. I need to balance the equation because they are not balanced. Okay, I have 2 chlorine here. I need to multiply by 2. So 2 hydrogen on the right side and the left side. So now I know that the mole ratio is 1:2:1:1. Okay, so I need to calculate the number of moles of hydrochloric acid. So you're given 14.6 gram of hydrochloric acid. Okay, 14.6 gram of hydrochloric acid. So likewise, mass over molar mass. Okay, your molar mass is 36.5 gram per mole. Okay, because 35.5 plus 1. So I calculate already, it will be 0.400 moles. Okay, so I determine the mole ratio. I'm interested only in the acid and the hydrogen because the question asks for volume of hydrogen. Okay, so HCl is to H2 from the equation is 2:1. 2:1. Okay, so mole ratio is 2:1 and I'm given 0.400 moles of hydrochloric acid. So if this is 0.400 moles, number of moles of hydrogen will be 0.200. So number of moles of hydrogen is this. What is the mass? Okay, so this will be 0.200. Then next step, okay, so question asks for volume. I have 0.200 moles. Okay, for volume of hydrogen, I know that molar volume for gas, because they are in gaseous state, this is only for gases, it's 24 dm cube per mole. 1 mole is 24 dm cube. If you are given 0.200 mole. Okay, so what I do is volume of hydrogen gas will be 0.200 mole multiplied by 24 dm cube per mole equals to 4.80 dm cube to 3 SF. Final answer is to 3 SF. Okay, alright, so this is how we do it. Okay, so to recap, I always have to balance the equation to find the mole ratio and always calculate to the number of moles. So moles, right, is like a common language. Moles like a common language. Okay, it allows you to compare from one to another. So I always use mole ratio. Mole ratio means I must calculate the number of moles. So 14.6 gram divided by the molar mass is this, 0.400 moles. And then from the mole ratio, I know that I need to compare only acid and hydrogen. Only acid and hydrogen. So acid versus hydrogen is 2:1. So 0.4 moles of acid will mean 0.2 moles of hydrogen. Okay, so how to get 0.2? I just divide by 2 according to the mole ratio. And then last part is to calculate the volume. 1 mole of gas is 24 dm cube. So it's 0.2 moles of gas will be 4.8 dm cube to 3 SF. Okay, so this is how I calculate. Alright, okay, likewise, I would like you to try the checkpoint question on page 7. Okay, using given mass to find unknown volume. Pause the video and complete it. Okay, so in this case, you are also given the balance equation. Okay, you are to find the volume, okay, of oxygen produced. So you are given 17 grams of hydrogen peroxide. Always calculate the number of moles. Okay, so in this case, from the reaction, okay, we know that the mole ratio is 2:2:1. So I need to calculate the number of moles first. So number of moles of H2O2, 17 gram, divide by 2 plus 32 gram per mole. Okay, so you will get 0.5 moles. Okay, your mass over molar mass. Okay, so I'm only comparing this oxygen and this hydrogen peroxide. So H2O2 is to O2. Okay, the mole ratio is 2:1. If this is 0.5 moles, this will be 0.25 moles. Okay, now what is the volume of oxygen? Okay, the molar volume is 24 dm cube per mole. So number of moles of oxygen is always equivalent to volume over molar volume. Okay, which is 24 dm cube. So here I want to calculate volume of oxygen will be number of moles multiplied by 24 dm cube per mole. Cancel away the unit. Okay, I realize that it is 6 dm cube to 3 SF. Okay, so always leave your answer to 3 SF. Alright, so this is how we calculate. Okay, so to recap, I have the balance equation, I have the mass, I want to find the number of moles first. So to find the number of moles, mass over molar mass. Okay, mass over molar mass, and I will get 0.5 mole of hydrogen peroxide. So mole ratio is 2:1. So if this is 0.500, I divide by 2, this is 0.250. So number of moles of oxygen will be 0.250 multiplied by 24 dm cube. And I will get 6 dm cube of oxygen. Okay, alright. And the last part is the same thing. We are using mole ratio again, just that instead of using a given mass, I'm giving you a given concentration. Okay, so now you are given the concentration, you find the volume. Okay, it's always the same thing. I always need to balance the equation first. So you know that this is a carbonate. A carbonate reacts with acid to form salt plus water plus carbon dioxide. Okay, so in this case, I will form my CO2, I will form my water, and my salt here will be sodium chloride. Okay, I balance it. since I have 2 sodium here, this one definitely multiply by 2. Once I multiply by 2, I will have 2 chlorine. I'll need to multiply by 2 here. Okay, so this is my balanced equation. Okay, so I erase this part. Now, then they ask, what is the number of moles of HCl? So you are given this. Okay, you need given this concentration. So we call the formula. Now this formula you need to remember. Okay, as long as you know this unit, it will be easy for you. You know this unit, mole over dm cube. It will be this is the unit for concentration. This is number of moles, and this is volume of solution. So in this case, my concentration is 5.00 mole per dm cube. So number of moles of HCl will be to multiply this together. Number of moles. Okay, so I multiply 5.00 mole per dm cube. I multiply by the volume. Now volume is in cm cube. I need to convert to dm cube. So how to convert? 50 divided by 1000, it will be dm cube. Okay, so once I converted, I'll get 0.250 moles of acid. So I'm only interested in volume of carbon dioxide. So I'm only interested in this and this. So I'll calculate the mole ratio. HCl is to CO2. Okay, HCl is 2:1. If I have 0.250 moles of HCl, divided by 2, 0.125 mole. Okay? So the number of moles of CO2. The number of moles of CO2 is 0.250 divided by 2 equals to 0.125 moles. So now the question asks, volume. Not done yet. I need to convert to volume. I know that it's 24 dm cube per mole. This is the molar volume. Okay, molar volume is for gases. So I'm given 0.125 moles of CO2. Okay, so what is the volume? So volume of CO2 is equivalent to 0.125 moles multiplied by 24 dm cube per mole is equivalent to 3 dm cube. Okay, so these two multiply together, you'll get 3 dm cube. And always leave the answer to 3SF. Even if it's exact, leave it to 3SF. Okay, even if it's exact, must leave it to 3SF. Okay, so this is how we calculate. Okay, so to recap, take a look at here. Acid plus carbonate, you will form salt, water, carbon dioxide. So we are only interested in acid and to calculate the volume of carbon dioxide. So I underline these two. First step, you're only given this value. So you can only work from here. So number of moles of acid is volume. Volume here, multiplied by concentration, you get the number of moles. Okay, so if you cancel away the units, you get this number of moles. So mole ratio of acid is to carbon dioxide is 2:1. So I simplify. If this is 0.250, this is 0.125 for carbon dioxide. So number of moles of carbon dioxide is 0.125 moles. Last step, I need to calculate the volume. So 1 mole is 24 dm cube. Always remember, gas, molar volume. 1 mole is 24 dm cube. 0.125 mole, okay, will be 3 dm cube. So the answer, always leave to 3SF. Okay? So actually, the whole thing is the same. It's just that it can be volume, it can be concentration, it can be mass. But the first step is always calculate the number of moles. Okay, always calculate the number of moles and just use mole ratio. Okay, alright. So this is the end of the first part, which is to use chemical calculation for your reaction. How do we calculate reaction? How do we calculate how much to use? How do we calculate how much they will produce?